Hello dear viewers, I Purvesh Nanavati welcome you all to my channel Welding Education. I'm going to discuss about weldability of quenched and tempered steels, chrome moly vanadium steels and high creep resistance ferritic steels. Well, it is difficult to cover all these kinds of steels and their weldability aspects into one lecture. So I'll be presenting the different steels into a couple of lectures. I hope you will enjoy my lectures. Well, to begin with the introduction of the quenched and tempered steel. These quenched and tempered steels have been alloyed with manganese, chromium, nickel, molybdenum and vanadium as an alloying elements, because these steels undergo a water quenching treatment and then subsequently tempered to acquire the sufficient strength and toughness. Boron in 50 parts per million range also present in this steel. Quenched and tempered steels have been used as a construction material in penstock pipes, earth moving machineries, ships, submarines, offshore structures. These structures demand high toughness coupled with high strength. Popular grades are ASTM F517, F533, F537, HY80, HY100 and HY130. The carbon content in low alloy quenched and tempered steels range from 0.1 to 0.23 weight percentage. This table shows many composition of typical quenched and tempered steels. ASTM F514 or F517. They have been classified under the various class, grade A, B, C, D, E, F and many more up to the Q. Here you will see a tensile strength. The tensile strength range from 760 to 895 megapascal and minimum yield strength from 690 as the minimum yield strength. And these different grades are varying slightly in their composition, but here you will also see a addition of zirconium, boron, vanadium, titanium as a micro alloying elements. There are many materials covered under this: A514, A517, then A533, A537, A543, A553, A678, and on the bottom you will be seeing three materials, advanced materials: HY80, HY100, HY130. They are being added with the vanadium and titanium as the microangular elements, and their specified yield strength is 550, 690 and 895 respectively. Here are the pictures of Penstock in Hydel plant. Now about welding of the quenched and tempered steels. The yield strength will vary from 50 to 150 kilopound per square inch. So talking about their welding aspects, there are three welding aspects we have to look into. First is the preheat and interpass temperature control. Second is heat input control during welding, and the use of low hydrogen consumables. So regarding preheat and interpass temperature, if preheat value is high, it will produce over tempered zone near fusion line, and if the preheat temperature is low, it will produce hard microstructure due to fast cooling. So the preheat and interpass temperatures are critical parameters with respect to welding. We'll see in subsequent slides the guidelines for the preheat and interpass temperature with respect to the thickness of the plate of the material. Second aspect is the heat input during welding to be carefully controlled. Taking example of a heat input in ASTM F516 grade F for 12.7 mm plate thickness, heat input is 2.76 kJ per mm, and for 19 mm plate thickness, heat input is 3.9 kJ per mm is recommended. So you can understand the heat input requirement according to the plate thickness. Then third point is the level of hydrogen. So low hydrogen electrode practice is mandatory for welding of quench and tempered steels. H4 or less is preferred for high strength materials. H4 means 4 milliliter hydrogen per 100 gram of weld metal deposits is preferred for high strength materials. Now this table is regarding suggested preheat and interpass temperature for arc welding, typically ASTM quench and tempered steels. So according to the thickness range, here in the thickness range for in mm, in here it is given in each, and for the various materials A514, A517, A533, A537, A543 and A678 materials, the minimum preheat and interpass temperature are given here in degrees Celsius and degree Fahrenheit. So for example, if your thickness is falling in the range of say 20.6 to 25.4, say approximately 1 inch, the minimum preheat for the material A514 is required is 50 degrees Celsius. But there is a note that with low hydrogen welding practice, maximum temperature should not exceed the given value by more than 66 degrees Celsius or in Fahrenheit 150 degree Fahrenheit. It means that with low hydrogen electrode practice, because this table is for the minimum preheat and interpass temperature, but the maximum value should not be greater than this value plus 66 degrees Celsius by more than this value 66 degrees Celsius, right? So this table gives suggestive minimum preheat interpass temperature range. It is abstract from the AWS Welding Handbook, Volume 4, 9th edition. Similarly, recommended preheat interpass temperature ranges for the HY80, HY100 and HY130 steels here is tabulated in this. So for this approx 1 inch, so 22.628 mm, for HY80 and HY100, the minimum preheat and interpass temperature requirement is 50 to 100 degrees Celsius, and for HY30 it is 95 to 135. This table is about maximum welding heat input for butt joints in ASTM A514 or A517 grade F steel. So here maximum heat input for joints at various preheats. So let us take a note of the footnote A. Suffix is given as a heat input limit for intermediate preheat in temperature and thickness may be obtained by interpolation method. Heat input limit may be increased 25% for fillet welds. Now, depending on the section thickness here, maximum heat input for joints at various preheats. It means in the previous slides we have chosen various preheat 20 degrees Celsius, 95 degrees Celsius, 150 and 200 degrees and like this. So in combination with the heat input we have chosen, we have to find out the heat input. Sorry, in connection with the minimum preheat temperature, we have to find out the various heat input combination. So for example, for a thickness of 25.4, we have to read the note B, and note B says that no limit with respect to heat input zone cooling rate with most arc welding processes. Welding processes of high heat input should not be used to weld these steels. So taking care of this note, so you know for 1 inch and more thickness, the heat input control is becoming very necessary, and for the lesser thicknesses, you know, heat input required in kilojoule per mm or in kilojoule per inch. It is given here in this table, but make sure the heat input selection is based on the preheat values that we have chosen according to the guidelines given in the previous tables. Now about the welding of quenched and tempered steels. Choices of the electrodes are from the AWS 8018G or similar class to AWS E131G or M class, depending on the strength and toughness of the base material. So